ठीक है या करना
थोड़ा थोड़ा सा जरा एक तो लिख लो। Good morning, learners and viewers. Welcome to the session of Maintenance Management MMPO 007. We will be starting with block 1, which is Maintenance Management and Overview, which includes 3 units. Unit 1 is Introduction to Maintenance Management. Unit 2 is Organization and Structure of Maintenance System. And Unit 3 is Maintenance Planning and Scheduling. So we will start with Unit 1, that is Introduction to Maintenance Management. Production organizations are usually concerned with converting inputs such as raw material, labor, and processes into finished products of higher value at minimum cost, satisfying the customer's need. Increased competition for timely delivery of high quality products has forced manufacturers to adopt automation. This has resulted in very high investments in plants and equipment. Maintenance is a combination of science, art, and philosophy. Its execution relies on science. Art of maintenance depends on individual aptitude, and its philosophy should fit to the operation or organization it serves. The focus of maintenance function is to ensure that all company assets meet and continue to meet the design function of the asset. Maintenance involves a combination of activities by which equipment or system is kept in or restored to a state in which it can perform its designated functions. It is important factor in product quality and can be used as a strategy for successful competition. Maintenance management is the management of all the assets owned by a production organization based on maximizing the return on investment in the assets. And this can be achieved by applying general management principles of planning, scheduling, organizing, and controlling to the maintenance function. In recent times, industrial plants have come up with a large number of automated and sophisticated machinery with complex control systems. With the coming of large size plants, investment costs have increased. Maintenance expenditure forms 3.5 to 5% of the sales turnover. The increased emphasis on equipment availability performance, quality, environmental conditions, and safety considerations has made maintenance function very important. Maintenance involves a combination of activities by which equipments or system is kept in or restored to a state in which it can perform its designated functions. The rationalization of maintenance function requires a deep insight into what a maintenance really is. Efficient maintenance is a matter of having the right resources at the right place at the right time to do the right job in the right way. What are the functions and objectives of maintenance? Industrial maintenance could be considered as a subsystem of an industrial organization, enabling the plant to fulfill its specified functions for a specified time. The main functions performed by the maintenance are cleaning, lubrication and topping up, adjustments or calibration, condition assessment, repairs and replacements. The maintenance subsystem requires the input of resources and information and provides output in the form of plant, useful life, availability, performance, quality, and safety. Maintenance management finds the most economical ways of performing the desired maintenance functions. The objective of a production department in any industrial plant is to achieve a planned output in a specified time. This planned output is normally a function of sales demand. It determines the long term and short term production plans, fixing the availability requirements of the plant. The plant, or some part of it, may be one of the following states. In production only, running maintenance can be carried out of production because of scheduled maintenance and will incur production loss. Unexpected breakdown and undergoing emergency maintenance, it incurs production loss and maintenance is difficult to plan. An unexpected breakdown and waiting of maintenance because of shortage of maintenance resources, which also incurs in production loss. Maintenance can be seen as a pool of resources, which includes math, spares, tools, and information, directed towards achieving desired availability and plant conditions following a maintenance plan. To decide on a maintenance plan, it is necessary to establish maintenance objectives. And these objectives could be compatible with the company objective and must be linked to profitability. Maintenance resources are used to prevent failure or to respond to failure or unacceptable deterioration. Maintenance resources cost, which can be direct cost of maintenance, and unavailability of cost, that is indirect cost of maintenance, affect company's profit. In general, the greater the level of maintenance resources, the lower the level of unavailability and the longer the useful life of the plant. The maintenance objective should be to minimize the sum of direct and indirect costs, taking into consideration the long-term effect of maintenance decisions. The main maintenance objectives can be to enhance overall equipment effectiveness by maximizing availability, performance, and quality rates and obtaining maximum return on the investments. And to extend the useful life of assets by minimizing wear and deterioration. To ensure operational readiness of all equipments at all times and for the emergency use. To ensure the safety of personnel using facilities and achieve acceptable safety. And to provide all these at minimum resource cost. Then comes your maintenance strategy. Any industrial plant consists of different functional units, and these units are divided into sections, and each section may have number of machines. These machines are further subdivided into sub-assemblies, and finally into the lowest level, that is the component. Maintenance is generally from the component level. When a component is unable to perform its desired function, it is said to have it has failed. And the loss of function could be contained at the component level or have consequences at the plant level, depending on the design of the plant. For example, on the amount of interstate storage or redundancy. Many of the machine components are designed with a useful life greater than the longest plant production cycle. In most cases, such short life components will have to be identified at the design stage and made easily maintainable at the component level without affecting plant availability and safety. Other machine components will fail for reasons such as poor design, poor maintenance, or mal-operation and may be expensive to maintain. The reason can be anything. It may require the replacement of higher level assembly. In addition, as the plant ages, components and assembly failures may increase. To keep the plant operating at the desired level of output and safety, a proper maintenance strategy is required. A maintenance strategy is concerned with identifying the components of the plant which might require maintenance, determining the most appropriate maintenance procedure, and then listing the procedure in the form of a schedule for a plant. The maintenance strategy is a function of production maintenance relationship and therefore in most situations will be subject to change depending upon the conditions prevailing. The commonly used maintenance strategies are breakdown maintenance or corrective maintenance, fixed time maintenance or preventive maintenance, condition based maintenance, opportunistic maintenance, or design out maintenance. So we will start with breakdown maintenance, that is, or corrective maintenance. In breakdown maintenance, the equipment is allowed to run till it breaks down and then maintain it and putting back into operation. Here, most of the maintenance tasks are repetitive to breakdowns or production interruptions. And the only focus of these tasks is how quickly the machine or system can be returned to services. In breakdown maintenance, most of the corrective maintenance work is poorly planned because of the time constraints imposed by production and plant management. As a result, manpower utilization and effective use of maintenance resources are minimal. Breakdown or reactive maintenance may cost 3 to 4 times more than the same corrective maintenance work when it is well planned. Another limitation of breakdown maintenance is that it concentrates maintenance work on obvious symptoms of the failure and not on the root cause. Corrective maintenance is limited to those tasks performed in order to restore the machine or system to acceptable operating conditions under after a fail has occurred. All corrective maintenance tasks are generally accomplished in 4 steps: fault detection, fault isolation, fault elimination, and verification that the fault has been eliminated. Fault elimination may be accomplished in any one of the 3 ways, depending on the nature of the fault. The first one is adjust, align, calibrate. Restoring the equipment of the system to acceptable functional condition by adjustment, alignment, or calibration of a circuit or component controlling a critical performance parameter. To adjust is to vary the setting of a controller unit until the performance parameter that is controlled is brought into an acceptable state or falls within an acceptable range. Adjusting the carburetor of an automobile for minimum fuel consumption at cruising speed is an example of carrying out adjustments. Repair: physically altering a fault component to restore it to its originally designated structure or functional condition or to another condition deemed acceptable. Commonly used rework methods include welding, soldering, patching, splicing, bonding, and reinforcing. Repair is particularly applicable to the correction of failures originating in faulty interconnections, utilizing media such as wiring, piping, hoses, mechanical linkages, or optic fiber. Third one is remove and replace. Restoring a malfunctioning machine or system to proper operating condition by removing the faulty component or subassembly and replacing it with a properly functioned spare component or subassembly with no repair involved. The second one is fixed time maintenance or preventive periodic maintenance. Here, maintenance is carried out at a predetermined interval or to other prescribed criteria to reduce the likelihood of an equipment or system not meeting an acceptable condition. Other prescribed criteria for determining the intervals would be based on fixed cumulative output, fixed number of cycles of operation, or usage hours. Here it is assumed that the mechanical failure and deterioration processes are dependent on time in a predictable way. The advantages of this maintenance strategy as compared to breakdown maintenance are: the number of unexpected shutdowns is reduced, risk of secondary damages caused by initial failure is reduced, better source utilization is there, and reduced product rejects, rework, and scrap due to better overall equipment conditions and improved safety and quality conditions. The actual lifespan varies from component to component, machine to machine. It depends on the several factors like load, lubrication, material quality, environmental conditions, etc. The limitation of preventive periodic maintenance are: the method does not give full protection from unexpected shutdowns. Some of the maintenance actions may not be necessary. Periodic maintenance causes an increased number of running failures. And if incidental failures are predominant, then periodic replacement may not have any positive effect on reliability. Commonly used preventive major tasks are: number one, servicing. This task that must be performed periodically to ensure that equipment will remain in proper operating conditions. And servicing includes replacement of consumables such as fuel and of depletable like lubricants, battery electrolyte, coolant fluids, and air in pneumatic tires. Best example to understand is the automobile, which we are using either as scooter, a car. They all go for maintenance and servicing. Minor adjustments and alignments, cleaning of permanent filters, and other critical services subject to contamination, and replacement of expandable filters and other short-lived items. Same is applicable to our industrial machinery system also. Then comes your Condition assessment and on condition remedial action. Condition assessment is the evaluation of the physical condition of equipment components known to be subject to wear or other form of deterioration. It is performed during scheduled inspections of the equipment. On the basis of this evaluation, it is decided whether the item can safely be permitted to remain in use or is until the next scheduled inspection or should be subjected to remedial action. Normally, condition assessment is performed on surfaces that wear out or corrode, that is, bearings, tire threads, DC motor commutators, and brushes. Mechanisms subject to misalignment or excessive play, that is, mechanical operating controls. Third one is items that accumulate contaminants interfering with operations. For example, radiator cores through which fluid coolant circulates. The third one is verification of hidden functions. Hidden functions are functions not exercised during the normal operation of the equipment or system. The circuit or subsystem performing the hidden function must be exercised periodically to verify that it is still capable of performing the function. Typically, hidden functions are emergency or redundant functions. A circuit breaker performs an emergency function, and a backup power supply performs a redundant function that enhances the reliability of the system. Both are hidden functions that require special techniques and where feasible built-in protest provisions for verifying that capability is available when needed. If at all possible, verification of the function should exercise the corresponding circuit or subsystem in every one of its operating modes. Fourth one is scheduled replacement. Scheduled replacement applies to the components that meet all of the following criteria. Failure of the component would endanger personnel or equipment or would reduce the operational availability of the equipment below the minimum acceptable level. The failure mode is unsuitable for conditions assessment, which is preferred preventive maintenance method. The third one is the useful lifespan of the component is substantially less than the intended operating life of the product and can be determined accurately. The proper selection and scheduling of preventive maintenance tasks required a planned maintenance management approach. Now comes condition based maintenance. In condition based maintenance, the equipment is maintained when measurements indicate an incipient failure. The condition of machine may be determined continuously or at regular intervals by monitoring vibrations, wear debris, temperature, and performance parameters. Any change of these parameters would mean a change in the condition or health of the machine. Implementing condition-based maintenance involves measurement or monitoring of appropriate physical variables or signatures of the machine using instrumentation and interpreting the signatures to indicate if maintenance of the machine is called for or not. The advantages of condition-based maintenance are it gives fairly effective protection from unexpected shutdowns. The machine is rarely stopped for unnecessary maintenance work compared to that in the periodic maintenance. In that case, machine has to be stopped. Damages may be prevented by reducing stress on the machine in case of incipient failures. And the condition checking after completion of maintenance helps in checking the quality of the maintenance work. However, there is always some degree of subjectivity involved in interpreting the measurements, and thus there is always a risk of planning maintenance too early or too late. The use of condition based maintenance is justified where condition based benefits prove to be larger than the cost of instrumentation, measurement routines, analysis, and follow up work. Opportunistic maintenance. Here, decision to perform maintenance is taken neither on the basis of condition assessment nor on the basis of elapsed time, since the last maintenance but is carried out in the event of machine shut down for maintenance or other reasons, that is change of gauge or die. The decision to prepone maintenance to the available opportunity is mostly based on the economics of preponing maintenance to that of sticking to scheduled maintenance and going for another downtime. The next one is design out maintenance. During the design stage of the production equipment, designers are primarily concerned with creating mechanisms to carry out set functions. Very often, and inadvertently, potential maintenance factors are not fully apparent. Otherwise, alternative designs would have been incorporated to reduce or eliminate them. These maintenance requirements could become fully apparent during operation and when highlighted by critical analysis should be viewed with the possibility of applying designing out techniques. Design out aims to eliminate the cause of maintenance. This is an engineering design problem, but it is often part of the maintenance department responsibility. It is appropriate for items of high maintenance cost where such cost arises either because of pure maintenance or poor design or operation outside design specifications. To effectively implement this policy, an information system is required, which may help in the identification of such system items. The choice is to be made between the cost of redesign plus reduced maintenance cost and the recurring cost of the best maintenance procedure. Some of the important steps which are involved in design out maintenance are identify the defect causing high maintenance costs, investigate the possible causes of the defect, identify the possible solution to eliminate the cause, and compare financial benefits against investment required, and assess the degree of risk with new modifications. Now, what are the guidelines for selecting the best maintenance strategy? The decision to select the best maintenance strategy for a given item is very important, and the selection of strategy is influenced by the following factors. First one is deterioration characteristics of item like mean time of failure and nature of deterioration parameters, if any. Second one is repair characteristics like mean time to repair of time after failure before unit function is affected. Third one is economic factors like material cost, repair cost, cost of unexpected failure, cost of replacement prior to failure, and monitoring cost. And the fourth one is internal, environmental, and statutory safety regulations, if any, with the maintenance. When the mean life of any item is considerably less than expected, the problem boils down to establishing the cause of this and, if possible, designing it out. A temporary maintenance procedure is often adopted until a more permanent solution is found. Normally, The ranking of maintenance strategy is in the following orders. First one is condition based maintenance, which is online. Condition based maintenance, offline. Fixed time maintenance, and operate to failure. Based on the above ranking, wherever possible, a condition monitoring procedure should be used. Now we move to second part of it, that is organization and structure of maintenance system. Now we have understood what maintenance is all about. Now we have to design the organization, the structure of maintenance system. The term maintenance organization refers to a group of individuals with a common goal who collaborate to maintain adequate machinery and equipment reliability in order to achieve efficient operations and high quality output. The organizational structure, which includes a clear authority hierarchy, clear maintenance procedures, and clear policies, will determine this. By minimizing and ultimately doing away with the need of maintenance services, the maintenance department new mission is to offer excellent customer support. This necessitates retooling the conventional rules. A maintenance organization is made up of three necessary and interconnected components, such as number one is resources, which are men, spares, and tools of specific size, composition, and movement. Second one is administration, the process of determining what, when, and how work should be done in accordance with the hierarchy of authority and responsibility. And the third one is work planning and control system. It's a tool for organizing and scheduling tasks as well as providing feedback on information that is necessary for the maintenance effort to be correctly directed towards its stated goal. Now, goals and objectives of maintenance organization. The typical goals and objectives of a maintenance organization are maximum production or availability of facilities at the lowest cost, quality, and safety standards. This statement is all encompassing and can be divided into smaller components. First one is maintaining existing equipment and facilities. This is the primary reason for the existence of maintenance organization. Unless the equipment or facilities owned by the plant are operating or functional, there is no advantage in having them. Second one is equipment and facilities inspection and services. And this is generally referred to as the preventive or predictive maintenance program. This activity is designed to increase the availability of equipment, facilities by reducing the number of unexpected breakdowns or service interruptions. Third one is equipment installation and alterations. This is not the responsibility of maintenance in all organizations, since outside contract personnel usually perform installation and alterations. As the maintenance will be maintaining the equipment, they should be involved in any alterations or new equipment installation so that they should be aware of what is being performed. Second one is identify and implement cost reductions. This objective is to for the maintenance organizations to find ways to decrease maintenance and operations expenses. By examining maintenance practices, adjustments could be made in tools, training, repair procedures, and or work planning to reduce the labor of material required to perform a specific job. Third one is provide accurate equipment maintenance records. A plant or machine history record is analogous to the medical history record kept by a medical practitioner. The regular perusal and analysis of plant maintenance records is the only sound and logical way of obtaining the information that will engage the management to take action based on the factual data to raise maintenance standards and improve cost effectiveness. Fourth one is collect necessary maintenance cost information. This objective is also related to the previous objective. Cost information is divided into general areas like labor, material, tools and equipments, contract work, lost production, and miscellaneous costs. Accurate cost information helps make a realistic maintenance budget and plan appropriate actions for further cost reduction. Fifth one is optimize maintenance resources. Making the most of the resources in hand is important in maintenance. Very few maintenance organizations will have as many as people, material, or tools as they could use. There is always a shortage of maintenance resources, so they must be used carefully. This can be achieved by proper planning and scheduling plant maintenance workload. Sixth one is optimize equipment life. Many equipment requires proper maintenance if it is to deliver its desired service life. Seventh one is minimize energy uses. Equipment and facilities that are properly maintained will require less energy to operate. And the eighth one is minimum inventory on hand. Since maintenance spare parts average 40% of the total maintenance budget, reducing the on hand quantities is a key issue. The cost of holding an inventory item in stock will average between 20 to 30% of the actual price of the item. What are the key issues affecting maintenance organization structure? First one is maintenance environment. In large plants, maintenance work will have to be carried out in a rapidly changing environment, which in turn may be due to the internal or external pressures upon the company. The maintenance manager may not be in a position to influence that environment to any great extent. However, he or she should be aware of the forces shaping this environment. The factors which can change the internal environment of the maintenance department and which the maintenance manager must say or must pay some regards to. As far as external factors are concerned, it could be competition, loss of market share, politics, environmental pressure, that is green issues, legislation, that is national and international, and labor mobility and new business in the area. And on the other hand, if we talk about the internal factors, that is the industrial relations, employees' motivation, incentive schemes, management changes, new product launches, and poor communications. Second one is coordination and communication. Only excellent communications, both vertical and horizontal, will be able to resolve the problem of coordinating and controlling the large volume of maintenance activities. Making use of numerous manual and computer-based planning systems may help in adequate labor utilization. These systems are essential in modern maintenance department if the work is to be handled effectively. Such systems must be supported by a high degree of control over what people do and when do they be effective. Third one is effectiveness and training. A successful organization will not only adequately control that which is to be done, but will also take steps to ensure that the services is cost effective by deploying the correct number of properly trained staff on each job and that too at the right time. This can only convince maintenance customers that the service they are receiving is effective. It is the job of the maintenance manager to take the initiative with regards to the training needs of the maintenance staff in respect of the new equipment. Fourth one is control and bureaucracy. Bureaucracy grows naturally in organizations which strive to be efficient. Bureaucratic organizations with many specialist hierarchies tends to display very good control within their specializations, but can become notoriously bad with respect to the interfunctional communication, flexibility in relation to change, red tape, and coordination. For a good organization, what is really needed is, in effect, two complementary organizations. One is largely bureaucratic to maintain control and get the work done. And on the other is non hierarchical, mixing disciplines and level in the business to solve problems. Fifth one is shift versus day work maintenance. The most capital intensive plant have to be operated round the clock to achieve maximum return on assets employed. In most of these types of operations, some shift maintenance will be necessary because of high cost of downtime, because of the expense of employing shift craftsmen, and the difficulty of organizing and controlling the work output. Most maintenance managers try to keep the number of craftsmen on shifts to a minimum, consistent with dealing competently with breakdowns and other emergencies. Next one is centralized versus decentralized maintenance teams. External influences and company culture have had a very significant influence on the way maintenance departments are organized in the plant. The idea of centralized control was not only appropriate to the needs of the business. By focusing on craft productivity and rigid control systems, individual initiatives was different. In trying to rigidly control the work of craftsmen to this extent, it doesn't matter whether it is decentralized or centralized, the outcome will be the same. By focusing on the maintenance needs of the plant as the first priority, many maintenance departments in large companies have to a large extent decentralized the first line maintenance team, but retained a centralized team to provide central workshop overhaul facilities, specialized craft and technical services, maintenance projects, supplemental resources, including contractors, the third party, spares, procurement, and repair. The decentralized team will work very closely with the production colleagues and in some cases have become part of the production team in the area. They have responsibility for carrying out sometimes centrally controlled maintenance plans and enjoy considerable scope for initiatives and healthy interaction with production staff. This is basically the centralized organization structure. In general, it is a general manager, procurement manager, but these are the three down the line, maintenance manager and production manager. And under the production maintenance manager, we have mechanical engineering superintendent and electrical engineering superintendent. And down the line comes the foremans. As far as decentralized organization structure is concerned, at the top is the maintenance manager and then the four divisions, that is the spinning, weaving, maintenance workshop, civil work may supply, and down the line they have maintenance foreman. What are the roles and responsibilities? Titles. job descriptions, and accountabilities. Despite all that have been said about the clarity of organization structure, over many years, it is still common practice to see deputy or assistant in large organization structures. The reason given for the existence of such positions and titles are many and usually include help the overworked managers to enhance the assistant's or deputy status and pay, and to cover the senior person's absence. Whatever the motivation for creating these appointments, they all almost always create confusion as to who is the team leader and therefore upward and downward authority and accountability. The main organizational evil of such appointment is that they split a great job into two or more parts. As a result, no one has sufficient management challenges. This usually results in deputy or assistant making out or managing a level further down, creating frustration for someone else. If the manager is generally overworked, then in most cases it is better to create two real jobs, an authority and accountabilities exclusive to them. Some of the roles and responsibility of maintenance managers are: first one is frontline supervision and in charge of the following. Frontline supervisors have control over the quality, cost, duration, and thoroughness of the work, as well as training and motivation. They also make tactical decisions to stay on schedule. Maintenance scheduling and planning, which includes job plans and estimates. Priority work schedule, maintenance records, indexes, and reports on performance versus goals. Arrange for the delivery of manpower, parts, and materials to the job site for the execution of work. Ensure that even low priority tasks have been completed. Reliability engineering includes the following: maintaining and analyzing equipments, data, and history records to forecast maintenance needs, ensuring maintainability of new installations, elimination, eliminating repetitive failures, providing technical advice to maintenance and partners, designing and monitoring effective and justified preventive and predictive maintenance programs, teams and leadership. Given the likelihood that someone of the organization will be made up of decentralized team, whether they may be mixed teams of specialists in one field or teams of people with variety of skills, it is wise to consider the responsibilities of the group leaders. As long as they have a clear objective and at least one natural leader among their ranks, this type of decentralized team can be incredibly effective if it is relatively small but well balanced with the appropriate overlapping of the skills and abilities. Evolving a maintenance organization. A maintenance organization resource structure should be designed to achieve the best possible balance between the use of the trade force and the caliber of service it offers. The resource structure determines the location, composition, size, and logistics of man, spare parts, tools, and information. The design seeks to maximize resources while maintaining desired resource response and work quality. Following are the major decision making areas. First one is choosing which trade and how many workers to assign to each workshop or plant area. Trade force composition and size. The effectiveness of work planning as well as the type and volume of the workload all play a role. Second one is choosing how much for the trade force will be devoted to maintaining a single plant. Area or unit type is known as plant specialization. The benefit of plant specialization is enhanced work quality due to increased plant knowledge and a feeling of ownership. Next is choosing the distribution and centralized organization of trade groups and workshop is the responsibility of the trade force. Commonly located centrally are shared trade groups. The benefit of decentralized group includes quick decision making and the sense of camaraderie among the local employees. Choosing how to resource maintenance work that takes place outside the typical daytime work is known as non-day maintenance cover. Shift work, extra hours, calling in, or a combination of these are other options. Choosing how and why to move resources around a site is known as the logistics of movement. Although secondary to the choice of resource location, these choices are nonetheless connected. Now, after the structure has been understood, now we move to maintenance planning and scheduling. Maintenance is a routine and recurring activity of keeping plant and machinery at its normal operating condition so that it can deliver its expected performance or service without causing any loss of time on account of accidental damage or breakdown. Maintenance is defined as all the actions taken during the operation stage of a machine to ensure that it continues to function as per the expected standards or even better. It also encompasses those actions which prevent the machine to lose any of its functionality or in other words prevents failure. Maintenance is a critical aspect of industrial operations that ensures that reliability, availability, and longevity of the assets, equipment, and facilities. This approach lead to unplanned downtime, increased cost, and reduced operational efficiency. With advancement in technology, maintenance strategies shifted towards preventive maintenance, which involves scheduled interventions to prevent failures. The evolution further led to predictive maintenance, which utilizes data analytics and conditions monitoring to predict failures before they occur, thus reducing downtime even further. Maintenance planning involves determining the task, resources, and schedules needed to execute maintenance activities, while maintenance focus control focuses on monitoring, evaluating, and adjusting the existing of these plans. Planning and scheduling are the most important aspects of sound maintenance management. Planning is the process by which elements to perform a task are determined in advance. Scheduling deals with specific time and phasing of planned jobs, together with the orders to perform the work, monitoring the work, controlling it, and reporting on job progress. Good planning is a prerequisite of sound scheduling. The primary objective of maintenance planning and scheduling are to minimize downtime, ensuring that maintenance activities are carried out efficiently and effectively to minimize production downtime and operations disruptions. Optimize resource utilization. Allocating resources such as labor, materials, and equipment in the most efficient manner to achieve cost effective maintenance outcomes. Ensure safety. Implementing safety measures during maintenance activities to safeguard personnel and assets. Extend asset life. Regular maintenance prevents premature asset failure, leading to longer asset life cycles and increased return on investment. Improve predictability. Through predictive maintenance techniques, Organizations can accurately forecast maintenance needs, enhancing overall operational predictability. Maintenance planning and scheduling involves several interconnected components, which includes work identification and prioritization. Identifying which maintenance tasks needs to be performed and prioritize them both based on critical safety concerns and operational impact. Resource allocation. Designing the necessary resources, including skilled labor, equipments, tools, and materials to execute maintenance tasks effectively. Then comes scheduling. Developing a well structured maintenance schedule that optimizes asset availability while considering production requirements. Fourth one is documentation, capturing the organization's maintenance data, work orders, procedures, and records to create a comprehensive history record. Next one is performance measurement, defining key performance indicators, that is KPIs, to assess the effectiveness of maintenance planning and control process. Effective maintenance planning and control offers numerous benefits, include increased operational uptime, improved asset reliability, enhanced safety, and reducing maintenance cost. Next is maintenance strategy. Maintenance strategy is the foundational framework that guides an organization's approach to maintaining its assets and equipments. It involves making informed decisions about when, how, and to what extent maintenance activity should be performed to achieve optimum operational performance, assets, reliability, and cost effectiveness. What are the types of maintenance strategies? Maintenance strategies can be broadly categorized into several approaches. First one is reactive maintenance, that is run to failure. This strategy involves addressing maintenance issues only when they lead to equipment failure. While it can be seen cost effective initially, it often results in unplanned downtime, increased repair costs, and production disruptions. Next one is preventive maintenance. Preventive maintenance is a scheduled approach where maintenance tasks are performed at predetermined intervals regardless of the asset conditions. This strategy helps prevent unexpected failure but can sometimes result in unnecessary maintenance if intervals are too frequent or tasks are not aligned with actual asset conditions. Then comes predictive maintenance. Predictive maintenance relies on real time data and condition monitoring to predict when maintenance is needed. By detecting early signs of deterioration, organizations can schedule maintenance just in time, reducing downtime and optimizing maintenance efforts. Proactive maintenance. Proactive maintenance goes beyond addressing symptoms to identify and eliminate root causes of failure. It focuses on continuous improvement, reliability centered maintenance, that is RC, and failure mode and effect analysis, FMEA, to optimize asset performance. Choosing the appropriate maintenance strategy depends on factors such as asset criticality, cost consideration, safety implications, and the organization's overall goals. A combination of strategies known as hybrid strategy might be used to address different asset types within an organization. Several factors play a role in determining the optimum maintenance strategy. The most important of them are asset criticality. High criticality assets may require more proactive strategies to avoid operational disruptions. Operational environment. Harsh or demanding environments might necessitate more frequent maintenance. Cost consideration. Budget constraints may influence the choice between preventive and predictive strategies. Data availability. Predictive and proactive strategies rely heavily on accurate and real time data. Implementing a maintenance strategy involves data collection, that is, gathering relevant data about asset performance, conditions, and historical maintenance. Second one is analysis, using data analysis techniques to make informed decisions about the appropriate strategy for each asset. Third one is planning, that is, developing detailed plans for maintenance activities, resource allocation, and scheduling. Fourth one is execution, carrying out maintenance tasks as per the selected strategy. A well defined maintenance strategy offers numerous benefits, including increased asset reliability and availability, reduced downtime and production disruptions, improved safety for personnel and equipment, cost saving optimized maintenance efforts, and enhanced operational efficiency and asset longevity. Maintenance planning. Planning in the context of maintenance means the process by which all elements required to perform a task are determined and prepared prior to starting the job. Planning is a process of detailed analysis that determines and describes the work to be performed, the sequence of associated tasks, methods to be used for the performance, and the required resources, including skills, crew size, man hours, parts, special tools and equipments, and an estimate of total cost. It also includes identification of safety precautions, required permits, communication requirement, and reference documents such as drawings and wiring diagrams. It addresses essential preparation, execution, and startup efforts. Work estimates and activation of required procurements are part of the planning process. With this, we will be concluding today's session.